Hi guys, so today we are going to solve some questions of circles. Let's move to the first question. A ring-shaped road has its outer diameter 100 meters and width 10 meters. Find its area and perimeter. Now this is a ring-shaped road that we have. So the outer diameter is 100. If the outer diameter is 100, the radius is going to be 50. Now the distance between the outer circle and the inner circle is 10. That means the inner diameter is going to be 100 minus 10 minus 10. So we have to subtract 10 two times because it's from the right side and also from the left side. So it is going to be 80. Diameter is 80. The radius is going to be 40. Area of this pathway will be area of the outer circle minus area of the inner circle. So by substituting the values in the formula of area of circles and subtracting these two areas, we'll get the answer as 900 pi. Now to find out perimeter, we have to find perimeter of this pathway. That means for that, we need to add up the outer line and the inner line because only in that case we'll get the perimeter of the pathway. So perimeter of the outer circle is 100, perimeter of the inner circle is 80. After adding it, we'll get 180 pi. Hence, option 2 is the correct answer. Moving to the second question. Given below is an octant of a circle with a rectangle of side 6 units and 2 units inscribed in it. Find the area of this octant. Now, octant is an eighth part of the circle. Eighth part of the circle means it will have the degree as 45 degrees. Because circle is 360 degrees, 360 divided by 8 will give us 45. Now, it's a rectangle, it is going to be 90 degree. Hence, we can say that it's a triangle forming, and the triangle is 45 is to 45 is to 90. Now, side opposite to 45 is 6. Hence, side opposite to other 45-degree angle is also going to be 6. Rectangle is going to be the opposite sides of rectangle are equal. Hence, 6 and 2 are going to be these sides. Now, it's a right angle triangle that we have. So what we'll do is we'll just construct a line, and this line is going to be the radius. Hence, it's a right angle triangle. So the sides are 6, 8, and the hypotenuse is going to be 10, as it's a Pythagoras triplet. Now, radius is 10, so we can easily find out the area of this octant. So basically, we are finding out area of the sector. So by applying area of the sector formula and substituting the values, we'll get the area as 12.5 pi. Moving to the next question. In the given figure, AD is 12, BC is 4. Find the ratio of area of triangles ADE and triangle BCE. Now, triangle ADE and BCE are two similar triangles. How? So, this is a vertically opposite angle pair. Now, angle subtended by the same arc RDC, by the same arc DC. These two angles are also going to be equal. Hence, we can say that by applying angle-angle test, these two triangles are similar. So, let's apply the property of similar triangle. So, ratio of side is 3 is to 1, as it's 12 is to 4, right? So, 12 is to 4 is 3 is to 1. Area is going to be square of the ratio of sides. By applying this property, we'll get 9 is to 1 as the answer. Moving to the next question. In the following figure, PS is 10, PT is 6, ST is 8. Find PQ. Now, let us assume this as A and A. Now, we can take them as tangents. So the opposites are going to be 8 minus A and 8 minus A. Now, these are also the two tangents that we have. So we can say, by applying the property, we can say that 6 plus a is equal to 10 plus 8 minus a. By solving this, we'll get the value of a, that is 6. Now, the two tangents to the same circle are going to be equal. They are going to be equal. That is the reason we equated 6 plus a and 10 plus 8 minus a. Now, PQ is equal to 10 plus 8 minus a, that is 12. Hence, option 4, 12 is the answer to this question. Moving to the next question. Three horses are grazing within a semicircular field. In the diagram given below, AB is the diameter of the semicircular field with center at O. Horses are tied up at P, R, and S such that PO and RO are the radii of semicircles with centers at P and R respectively. S is the center of the circle touching the two semicircles with diameter AO and OB. The horses tied at PR can graze within the respective semicircles, and the horses tied at S can graze within the circle centered at S. This is the diagram that we have. The question says the percentage of area of the semicircular diameter AB that cannot be grazed by the horse is nearest to what? So let us take it as RR. Now R is the radius. These are the two semicircles that we have. So let us assume the radius of the circles as R. So AB is going to be R plus R plus R plus R, that is 4R. Now this is the height of the triangle. So let us take the radius of the upper circle as A. So the left side is going to be R plus A and the height is going to be 2R. So if this height is 2R, the remaining part is going to be 2R minus A. Now this is a right angle triangle. So we can apply Pythagoras theorem. By applying Pythagoras theorem, we get R plus A square is equal to 2R minus A square plus R square. We'll get the value of R as 3 by 2A. So let us assume R as 3 and A as 2. Because if we transfer A to the left, it will become R upon A is equal to 3 upon 2. So we can equate R with 3 and A with 2. So we have to find out the area of the shaded region. That is equal to area of semicircle with radius 2R minus 2 into area of semicircle with radius R minus area of circle with radius A. So if we subtract these three things, we'll get the area of the shaded region. So after substituting the values and putting in the formula, we'll get the area of shaded region as 5 pi. Required percentage is going to be 5 pi upon pi into 36 by 2. After solving this, we'll get 5 by 18 and 5 by 18 is 28%. So 5 by 18 into 100 will give us 28%. Moving to the next question. A punching machine is used to punch a circular hole of diameter 2 units from a square sheet of aluminium of width 2 units as shown below. The hole is punched such that the circular hole touches one corner P of the square sheet and the diameter of the hole originating at P is in the line with a diagonal of the square. Next question says the proportion of the sheet area that remains after punching is what? And the seventh question says find the area of the part of the circle round punch falling outside the square sheet. Now this is 2. This is the diameter and this is the diagonal. So if this is also 2, diameter of the circle is also 2, the radius is going to be 1. Radius on this side is also going to be a 1. And we can form a square in this way. Now, when it forms a square, we will have to apply the properties of square, that diagonals of square bisect at 90 degree and all the angles of square are 90 degree. So proportion of the sheet that remains after punching is equal to 2 into 2 minus 1 by 2 into 1 into 2 minus 1 by 2 pi r square. 1 by 2 pi r square is the area of the circle upon 2 into 2. 2 into 2 is area of the square. So after solving this, we'll get the answer as 6 minus pi upon 8. Seventh question says, find the area of the shaded region. So for that, we'll have to find the area of the shaded part. So it is going to be area of the circle, that is 1 by 2 pi r square minus the area of the punch part, that is minus 1 by 2 into 1 into 2. So after solving this, we'll get the answer as pi minus 2 upon 2, that is option 4. Moving to the next question. PQ and RS are parallel chords of a circle with center O. X and Y are the midpoints of these chords. PQ is equal to 14 centimeters, RS is equal to 6 centimeters, and XY is equal to 4 centimeters. Find the radius of the circle in centimeters. So there will be two cases. First case is chords are on the same side of the center. So these are the chords that we have, 14 and 6. After applying the midpoint part, we'll get 7, 7 and 3 and 3. The distance between them is 4. Now, if we join this, if we construct this, we can see that there are two right angle triangles forming and the hypotenuse are the radius, are the radii. So let us assume the radius as r. Now, this is a right angle triangle forming, so we will get the value of r by applying Pythagoras theorem. Similarly, we'll assume that the smaller triangle has the height d. So, by applying Pythagoras theorem to both the triangles, so first triangle is the smaller one, that is r square is equal to d plus 4 plus 3 square, and the second one is r square is equal to d square plus 7. Actually, second is the smaller one, first is the bigger one. Bigger one means the triangle with the height d plus 4, the entire height. Now, after solving these two things, we'll get the value of d as 3, because both these things are equal to r square. R square means they has to be equal. So d square plus 7 square is equal to d plus 4 the whole square plus 3. After solving this, we'll get the value as d of value of d as 3. Once we get the value of d as 3, we can definitely say that it's option 2, that is square root of 58. Now we just have to substitute that in r square is equal to d square plus 7 square. So after substituting the value of d as 3 in r square is equal to d square plus 7 square, we'll get the answer as square root of 58. Moving to the next question. Now we have to consider the second case also. Second case is chords are on the opposite side of the center. That means in this way. Now everything is going to be the same, but the diagrams are going to be different. So the diagram will be in this way. Now, if I assume the smaller height as d, the other height is going to be 4 minus d. Again, by applying Pythagoras theorem, we'll get r square is equal to 4 minus d the whole square plus 3 square. and r square is equal to d square plus 7 square. By solving this, that is by equating these two, we'll get the value of d as minus 3, but d cannot be negative. If it cannot be negative, that means this case is going to be eliminated. Hence, option 2, square root of 58 is the final answer. Moving to the next question. A point P lies inside a triangle ABC such that PA is equal to PB is equal to 10. Angle APB is equal to 60 degrees. Find the length of PC if the measure of angle ACB is equal to 30 degrees. This is a triangle. P is the center. PA is 10, PB is 10, and it's 60 degree. C is 30 degree. Now C has to be 30 degree because we have learned the property angle at which point is half the corresponding vertex angle. So this is also going to be 10. Now PC is also going to be 10. Also, there's one formula that is angle ACB is equal to half angle PAB. Sorry, half angle APB. That means angle ACB is half angle APB. So half of 60 is 30. Hence, angle C is going to be 30. And if we join PC, we'll still get 2. We can form a circle. So this is going to be a circumcircle, and PA, PC, and PB are going to be circumradius. So we can say that the answer is going to be 10 centimeters. That is option 3. Thank you.